So let's start with monotonicity of functions. So basically a monotonic function can be classified into these categories. What are the four categories that you have? Strictly increasing, strictly decreasing, non-increasing, and non-decreasing. So we can classify a monotonic function into these four categories. Strictly increasing function means usually if x1 is less than x2, where x1 and x2 are any two inputs, you will have the same inequality between the outputs. For this, it will be reverse. And for non-increasing, you will also have does not increase. So it will decrease. So or remain constant like this. And for non-decreasing, does not decrease means it will either increase or remain constant. So f of x1 less than or equal to f of x2. So this is the definition basically. And if you have to write down the condition on derivative, so we basically write f dash x greater than 0 for this, f dash x less than 0 for this. Non-increasing, what will you write? Non-increment does not increase means either decrease or remain constant. So what would you write? Less than or equal to 0. And last one greater than or equal to 0. So basically if you draw graphs also, so for strictly increasing, you observe if there is an interval called AB, within that if you choose any two inputs x1 and x2, you can see when x1 less than x2, f of x1 is less than f of x2. So this is strictly increasing. Here also you see the same criteria will hold. If you choose any two inputs x1 and x2, the same inequality will hold. Here also it is going to satisfy the same inequality. And here the slope of this line is always positive. So f dash x is positive. Here the tangent drawn to this curve will always make acute angle with the axis. So slope is positive means f dash x is positive. Here also the tangent will make acute angle with the axis. So slope is positive. So f dash x is positive. So overall, all the three will represent strictly increasing function. These are the graphs for strictly increasing function. You can note this. This will be common for all of them, and f dash x is positive for all of them. So if you want to write about f double dash x also, so for a line, double derivative will be 0, and for a curve which is concave down, double derivative will be positive. Which is concave down will be positive or negative? Negative. And concave up it will be positive. So you can also write down double derivative. So let's say, for example, out of these three, I'll take second case. So for this, f dash x is positive and f double dash x is negative. Say suppose I have x1 here and x2 here, and the graph is y equal to f of x. This point is x1 comma f of x1. This point is x2 comma f of x2. So join this, you will get a chord AB. So you'll get a chord called AB here. So if I show the midpoint of this chord, it will be somewhere here, some m. What will be the coordinates of the midpoint? x1 plus x2 by 2, f of x1 plus f of x2 by 2. So you drop a perpendicular, the x coordinate of this is x1 plus x2 by 2. Y coordinate is f of x1 plus f of x2 by 2. If you extend it backward to cut this curve in some n, what will be the coordinates for n?
f of x1 plus x2.
X coordinate will be the same only because it is on the same vertical. And y will be f of x. So f of x1 plus x2 by 2. So you have to just substitute in that curve itself. Y equal to f of x dimension. So put x value here, you'll get this value for n. So out of m and n, which is above? N is above. So y coordinate of n should be greater than y coordinate of m. Geometrically, because n is above m. Which means f of x1 plus x2 by 2 is greater than f of x1 plus f of x2 by 2. So to solve some inequality questions, we use this kind of results using monotonicity. So this you can note. So I could have taken third case also. I just took second case as an example. For third case also, we can take similar example, but inequality will reverse in that case. Because here n is above m. In this graph, n will be below m. That will change according to this condition, f double dash x. Now the same thing, if I extend for 3 points. Say I'm choosing some random point A here, B here, and C here. Join this to form a triangle. So the curve is again y equal to f of x. And this point is x1 f of x1. This is x2 f of x2. And this is x3 f of x3. So with the 3 points, I formed a triangle. If I mark the center out of this, mark it slightly left side. So what will be the coordinates for centroid of triangle ABC? x1 plus x2 plus x3 by 3, f of x1 plus f of x2 plus f of x3 by 3. So now if I drop a perpendicular like this, here also I can drop. This is x1, this is x2, this is x2, this is x3. And this is the x coordinate of centroid, x1 plus x2 plus x3 by 3. You extend this backward to cut the curve g dash. What will be the x coordinate for g dash? If they lie on same vertical, x will be same. And what is the y coordinate? It lies on the curve y equal to f of x. So y coordinate will be f of x coordinate. So f of x1 plus x2 plus x3 by 3. Again, which point will have greater y coordinate, g or g dash? Yg will be less than yg dash. And if ABC coincide, these two can coincide, but if they don't coincide, it is only less than. So yg will be f of x1 plus f of x2 plus f of x3 by 3 less than yg dash will be f of x1 plus x2 plus x3 by 3. So if you just go back and see, whatever result you got with 2 points, you got with here you got greater than or less than. Here you got greater than. And here, which one should I write first? I wrote it the other way. First I have to write, okay, I wrote the other way. The same thing only. So what does this conclude? F of x1 plus x2 plus x3 by 3 greater than f of x1 plus f of x2 plus f of x3 by 3. And for n points, I just showed with 2 points and 3 points. For n points, what would be the result? F of x1 plus x2 plus x3 up to xn by n will be greater than f of x1 plus f of x2 up to f of xn by n. This generalized result you can remember. And equal to sign you can put when the coincide. Like for example, if ABC coincide, G and G dash will coincide, then you can put equal to. Otherwise, it's only less than or greater than. This is 3 here, not 2. So this result you got when you took it concave down. So if you are choosing it concave up, then the result will be reverse. you'll be getting it reversed like this. The coordinates would be something like this. So for n position points chosen on the curve, we can satisfy this relation. So as an application, suppose if there is a trigonometric question like this. In triangle ABC, prove that sin A plus sin B plus sin C is less than or equal to 3 root 3 by 2. So for this type of problems, you know sin x graph will be like this between 0 to pi. And why I took only 0 to pi? Because angles of triangle will lie between 0 to pi only. So take any 3 points on the graph. So here you will mark angle x, and here you will mark y is sin x. So the graph will contain point like a comma sin A, b comma sin B, c comma sin C. So if I choose centroid, what condition should I use? It is concave down. This one. So x1, x2, x3 are ABC here. So I can directly write f of A plus f of B plus f of C by 3 less than f of A plus B plus C by 3. And equal to sign you can write down when ABC are equal. For equilateral triangle, equal to will happen. And if this is your f of x, what is f of A? Sin A. F of B is sin B. F of C is sin C. So you'll get sin A plus sin B plus sin C by 3 less than or equal to what is A plus B plus C? Pi. So right hand side is nothing but f of pi by 3. What is f of pi by 3? Sin pi by 3, which is root 3 by 2. So if you cross multiply, you will get this result. And the maximum value will occur when it is equilateral. That will be 3 root 3 by 2. So this kind of problems in trigonometry also can be solved using monotonicity concept. So similarly, you can do problems related with cos or tan also in the same manner. Then if you have to write about increasing function, strictly increasing is done. If it is increasing function. Sometimes in the book they are taking increasing and strictly increasing same. These two they are taking it as same in some books. And similarly, decreasing and strictly decreasing they are taking same. So they are not using the word strictly. And the other case is non-increasing, non-decreasing. Non-increasing function, non-decreasing function. So if they don't mention the word strictly also, you can just take this because they are using the same thing in the book mostly. And for this, f dash x is greater than or equal to 0. They are taking only greater than, greater than or equal to, and decreasing. And non-increasing does not increase means decrease or remain constant. Non-decreasing does not decrease, increase or remain constant. So these are the things you are going to use while solving the problems. Apart from this, double derivative is used in the problems which I mentioned just now. I explained that kind of methods. We'll use double derivative also. Okay. So if I have to draw different graphs, So if you have something like this, this, and this, so does it come under strictly increasing? Which case it is? X1 less than x2, f of x1 is less than or equal to f of x2. This is non-decreasing. That means increase or remain constant. Non-decreasing means increase or remain constant. So because you observe here, it is remaining constant in between these two. Like if this is some A, C, D, and B, between A to C, it is increasing. Here it is remaining constant, then increasing. So it includes both less than as well as equal to. Because if I choose x1 and x2 in between, less than will hold. If I choose them in here, equal to will hold. And here again, less than will hold. So it's a mix of both. It is a non-decreasing function. The graph will be like this. Other possibilities could be, it can be a curve, then a line like this. Or here also you can have a curve. Like that, you can have different possibilities. So in between C and D, it is constant. A to C, it is strictly increasing. D to B, it is strictly increasing. This also comes under the same category. Like that, you can draw several cases. But one or two are enough to understand. We need not write all of them.